Go live. Is it going to work today? Oh, we're live. It actually works. Did anybody watch it yesterday, by the way? Our class? It was only our second video ever. All right. Okay, so we are going to now learn how to factor anything. Okay?
Anything.
Pretty much anything. So here we go. We've got what we call, this is 3.4, which is polynomial and rational functions. Okay, and we're going to give you a very cool theorem. This is much better than yesterday's two theorems. You'll actually use this one today. This one's called the rational zeros theorem, THM for theorem. Okay? So, if the polynomial function, and when we get into the stuff here, a sub n to the x sub n, equals p of x, plus a sub n minus 1 x to the n minus 1, plus, until you get all the way down to a1x plus a sub 0.
What does the dot stand for?
Everything in between.
Oh.
Okay? So if the polynomial function that looks like this has integer coefficients, okay? So we are limiting this to integers. Then every rational zero of P is of the form P divided by Q. I'm going to run out of space really fast. Where P is a factor of a sub 0 and Q is a factor of a sub n. Okay? So in a nutshell, what this means, and this is a very important theorem that you are going to use, unlike yesterday's stuff, okay? What it means is this first term and this last term, okay? These are your P's. And actually, let me just look, well, here, I'm gonna change my box. These are your Q's, okay? So those are your, so you need to find your P's and Q's, okay? All right, so I wish I wasn't out of space because I would normally leave that, but does everybody have that written down so that I can erase it? Because I need the space. We didn't have this big screen in the way. Part of me almost wants to right over there, but then I can't aim my camera over there. Are we good?
Yes.
Okay. All right, so I'm going to erase that, but this is a very, very important theorem. Here, I am going to do that so you can see the whole board, hopefully. Okay. So this is a really cool theorem. And here's what it means. Okay. So let's do an example where I've got some p sub x equals x cubed minus 3x plus 2. Okay? All right, we are going to factor this. Okay? So let's talk about, in fact, you will have some homework question that will say list all possible zeros. And when it asks you that, it's relying on the rational zeros theorem. Okay? So let's list all my P's and my Q's. What are all the possible factors of 2? Let's pick on Mary. All the possible factors of 2 are 1 and 2, right? And it could be plus or minus, right? So you could have a plus or minus 1. You could also have a plus or minus 2. Okay? Now, since that was such a hard question, I'm going to ask you another one. What are all the factors of that term right there? Plus or minus 1. Okay? So what the rational zeros theorem says, these are all the possible zeros. What I'm going to do is I'm going to take 1 divided by 1, which is plus or minus 1. And I'm going to take 2 divided by 1, which is plus or minus 2. Okay? Now, how many solutions am I going to have at most, Joshua?
What was the question?
How many possible zeros am I going to have of this? What's the most number?
2.
Nope.
1.
Nope.
I don't know. Probably 3.
3. There we go. How did you get the 3?
Because there's
Because
it's cubed.
It's your degree. Your degree is going to be the maximum number. Okay. So we're going to have at most three possible zeros. I've got 4 to choose from. Okay. We're going to do a lot more. They're going to have a lot more here, but we've only got. So the thing is, I've got only 4 choices. So that's not too bad. You're going to have a lot more choices with some other problems. Okay. So Natalie, if you were going to guess plus or minus 1, plus or minus 2, which one would you guess first?
Probably start by plugging in positive 1.
Positive 1, okay. We're going to try and see if 1 is a possible solution. And I kind of gave you a hint, Mauricio. What am I going to do?
Synthetic division.
Synthetic division. And so the coefficients are?
1.
1.
Negative 3.
Oh,
No, 0.
you
0,
promised
0.
me. 0.
Negative 3.
Negative 3.
Plus 2.
Positive 2. Okay? Now, Natalie, you guys are going to tag team, I guess. Natalie, can you help me with this? You got a question?
It just why is the 0? Like I know that like don't forget it and we promised you and all that, but why do we put a 0 there?
Why is there a 0 there? Who knows the answer to that question? Natalie.
So we got x3 and we have x to the 1, but math's kind of OCD, so we need an x to the 2.
We need to, yeah, math is OCD. Did you hear that?
Yeah.
Okay, it's OCD. So you gotta have a place for the x squared term.
Okay.
And since there's nothing here, you gotta put a 0 in to fill it.
Okay. Oh, okay, gotcha.
Okay, so this is the x cubed, x squared, x term, and then the constant term.
It makes sense now.
Okay. All right. So Natalie, help me do the synthetic division.
All right, so bring down 1.
1.
1 times 1 is 1. Minus 0 is negative 1.
0 and 1 is positive 1.
Wait, my math.
We're adding,
Yes.
right?
Yes. Okay.
1 times 1.
1.
Negative 3 plus 1.
Negative 2.
Negative 2 times 1.
Negative 2.
Oh, look at that. We lucked out. Okay? You're not going to always luck out and get a thing there. Okay, so if 1 is a 0, what is the factor that turns into? Somebody said it. Who said it?
X minus 1.
X minus 1. And these become what? If I started with an x cubed, this becomes an x squared. This becomes x minus 2. Okay, so that's what I've got left. That is easily factorable. Eric can do it, right?
X plus 2, x minus 1.
X plus 2, x minus 1. Plus 2 minus 1 is plus 1. Negative, a positive times a negative is a negative. Perfect. And so your zeros are where? Skylar? Where's your 0?
Where it'd be 1,
At 1, and it has a multiplicity of?
1,
Are you sure?
no, 3,
No?
no,
How many x minus 1s do I have?
no, 2,
2, so I've got a multiplicity of
2.
2. and I have x equals
-2
-2,
with a multiplicity of 1.
multiplicity of 1. Okay, so the fact of the matter is, Natalie was a good guesser when she picked 1. I could have also picked -2 and it would have worked. Okay? So, the idea here is hopefully you can get it down to a nice quadratic and then you can factor. Okay? So that's the rational zeros theorem. List all your possible zeros. There's going to be a lot of guess and check. Hopefully you get a 0 here. And if you do, then you know that's a factor. And then you can either repeat the process or you can factor this. Does that make sense? That's what we're going to do today. We're just going to do harder problems. That was a nice, easy one, right?
So all you have to do is pick one, and it should give you the rest of them. If it is.
Pick one, and hopefully you get a remainder of 0.
And if it does.
And if it does,
you get the rest of
keep
those
going.
Zeros.
Yeah, keep going.
Okay.
If it doesn't work, if I had picked, would -1 have worked? No, -1 would not have worked, so then I would have thrown it out. Okay? Now, good. So in a nutshell, that is what you're going to do. It's going to be a lot of guess and check. Okay? Now, would you like to have fewer guesses?
Yeah.
Okay? Because right now, I had no idea which of those it was, right? Okay? So we do have some other theorems. Basically, your homework is you're going to be doing this. Okay? We do have a few other theorems here. In fact, well, I'm going to leave that there, okay? And so we have what's called, and I don't know that these are as helpful as the rational zeros theorem, Descartes' rule of signs. Okay? Now, by the way, let me just mention this really quickly. You see this nice graph here, nice rectangular graph. We actually call this the Cartesian coordinate system. Did you know that? Did you know that was what it was called? Who knew that? Okay, do you know why it's named the Cartesian coordinate system? Because of this guy, we just chop off the des. He's the guy who came up with it, Cartesian coordinate system. Yeah, he's a very smart guy, very smart French guy. Anyway, so remember on this problem that we didn't know if they were positive or negative. Okay, so he's got this Descartes rule of signs. Okay, and rule number 1 is the number of positive real zeros of P of X is equal to, or oh, sorry, is equal to the number of variations in sign of P of X, or is less than that by an even number of zeros. Okay? All right, so what that means in the case of the problem that we just did, okay? So if I go from, okay, this is a positive execute. You all agree with me on that? Okay? So if I go from positive to negative, that's one sign change. If I go from negative to positive, that's 2 sign changes. So one of the things I could have done is I would say at most, I will have 2 positive zeros. Okay? Actually, I should say it this way. At most, 2 positive zeros, 2 or 0, because you always have to go by an even number. Okay? So I'm going to have at most 2 positive zeros, or I will have 0 positive zeros. Okay? Now, we also have rule number 2, which says the number of negative real zeros is equal to the number of variations in sign in p of minus x, or is less than that by an even whole number. Okay? Now, rule number 2 is really not as fun, okay? But I'll do it anyway. Okay? So what it says is, basically you need to define p of minus x. And then we're still going to count the number of variations in sign. Okay? So p of minus x is going to equal negative x cubed minus 3 times minus x plus 2. Okay? Now, when I simplify this, this becomes negative x cubed. This becomes positive 3x. This becomes plus 2. Okay? So, if I want to know the maximum number of negative zeros, okay, I need to count my changes in sign. I've got a change in sign here, right? That's one change. There is no change in sign from here to here, right? Okay? So, according to rule number 2, I'm going to have at most 1 or, now I'm not going to have negative 0, 1 or 0. Normally I would count down, okay? If I had 3 changes in sign, I would have 3 or 1 or 0 negatives. Does that make sense? Okay? Now I could have told you that if I'm going to have at most 2 here, and I've got 3, I'm going to have at least 1 negative. Does that make sense? Because I've only got 3 possible real zeros. Okay? Now, what I will say is this. I don't use this very much. Okay? Where I would use it, I especially don't worry about that. I don't worry about rule number 2, but it is a little bit useful. Okay? And I could ask you a test question on that. But what I will say is this. Okay? This is more useful when you're into like x to the 7th or x to the 8th and you have to factor it, okay? Then this is going to be more helpful. Now remind me, I already erased the answers. What were my zeros? We just figured out.
1 and negative 2.
1 and negative 2. This one had a multiplicity of 2, right? Okay? So I had 2 positive zeros and I had 1 negative 0. Okay? This one counted twice though, right? Okay? So the idea here is, if I were doing this along, remember we picked positive 1 first, right? I would know that if I had at least 1 positive 0, I would have to have at least another one. In this case, it doesn't help me narrow it down. But let's say that this was up to x to the 7th, and maybe I did my change of signs, and I would only have, say, 2 positive zeros, and I found both of those positives, I wouldn't try any more positives because I know they wouldn't work. And that's where this is a little bit useful. The negative is just a big pain because I don't really want to figure that out very badly. But let's say, for example, this was x to the 7th. Okay, minus 3x plus 2, okay? I've still got positive, negative, positive. So even though this is x to the 7th, I'm going to have at most 2 or 0 positives. let's say I found both of my positives, okay? Let's pretend that that was the answer. I would not try any more positives anymore. If this was x to the 7th, I really should figure this out, but I'm going to ignore it for a minute, because if this is x to the 7th, how many possible zeros am I going to have? 7. I'm going to have 7. And if I've already found the first two and they're both positive, I'm not going to try any more positives. How many negatives could I have? 5 or 3 or 1. And actually, because this is x to the 7th, I'm going to have a minimum of 1, right? Because if this is an odd function, it's got to cross somewhere. No matter what, it's got to cross. So I probably shouldn't say 0 here. I'm going to have 1. I'm going to have a minimum of 1 negative in that case. Okay? No, I guess that's not true, because it could cross here and it would be a positive 0. It wouldn't be a negative 0. So I guess I'll leave that there. It could be 1 or 0. Okay? But the idea with Descartes' rule of signs, you're going to count the sign changes on the positive side. That will give you your positive zeros. You're going to do the same thing with the negative, and that will give you at most the number of negative zeros. Okay? That can be very useful, especially when you're getting into this, so that you can narrow down, oh, well, I'm not going to try any more positives because I've exhausted all of my positives. They have to be negative from here on. Okay? Now, I didn't cover my upper and lower bounds. And I really only did one problem. Oh, but I did answer that question. As far as homework, I think we can do that. We'll just start with the first page. I think you should be able to do through at least 19. You might be able to do more than that, but I'll just make the quiz on up to problem 19 on your homework. We'll continue this tomorrow. 3.4, we'll talk about upper and lower bounds. Once again, these are ways to kind of, you don't have to do so much guessing. You're still going to have to do a fair amount of guessing on this, okay? So quiz tomorrow, 3.4 up through problem 19.
Thank you.